Alright, today's the day that you become a man. Not really. Today's the day that you learn how to write the linear equation of a line given just the ordered pairs. Okay, so we're going to pretend that 2, 1, and 4, 2, there are ordered pairs that fall on the line, and even without graphing the line, we can figure out the linear equation that represents that line. Now, uh, sort of the obvious thing with this is, well, why don't you graph these? Wouldn't that just be easier in the first place? And believe it or not, the answer to that question is yes. Why not just graph these? So assuming you know how to graph points, I'm going to go ahead and graph these for you. You get these two. And if I draw a nice straight line, that line actually wasn't perfectly straight. There we go. It's a little bit better. You should be able to see a nice slope and a y-intercept. Speaking of which, would you mind finding me the y-intercept really quickly? I sort of gave you a hint with where I pointed my mouse. It should be right there. And that point is just the origin 0, 0. The y-intercept is 0. That's nice and easy. Now what's the slope of this? If you found the slope correctly, you should have found that there was a rise of 1. There was a run of 1, 2. They were both in the positive direction, so we have the fraction positive 1/2. And knowing that, we can plug these values in to our formula for slope-intercept form, which of course is what? That's right, y equals mx plus b, where m is 1/2, b is 0. For that reason, when you plug these in, what do you actually get? If you're right, the b actually is 0, so it goes away, and you're actually left with just y equals 1/2 of x. And that is the linear equation. It represents the line defined by these two ordered pairs. Woof! On a scale of 1 to 5, how do you feel about doing these kind of problems where you get a graph? That's good. However, sometimes these problems aren't always this nice. I'm going to go ahead and leave our slope-intercept form on here. I'm going to delete everything else. The reason is I want to show you a new ordered pair. What if I give you an ordered pair like 3, 6 and another one like -2, 2? This time, we're going to go ahead and try it the same way. We're going to go ahead and graph these. Here's 3, 6. Here's -2, 2. And when I draw my line, let's pray that I can draw it straight. That's a little wavy. Even though it's not straight, you can probably tell that where this line is going to end up crossing is somewhere right here between 3 and 4. And my question is, do you have a guess as to what that point is? Honestly, your guess is as good as mine. There's no easy way to find it. Now, we could probably use proportions to figure out, okay, if I go up, by a certain amount and over, then I could figure out approximately if I go over 2, how far I went up. I could even, bust out a ruler and specifically measure exactly how far between 3 and 4 that is, but that is all of one big hassle. Now, since I've already drawn my graph, yes, I could easily find the slope. There's an even easier way than even messing with the graph and doing all of that, and that has to do with doing this by hand, and that's using our formula. You guys remember that formula, how to calculate slope? If you got it, it should be y2 minus y1, x2 minus x1. Some of you are so used to that it's just second nature to you. For those of you who aren't, I don't actually like this formula because it implies that, like, if you change the order, like, I don't know, if I put -2, 2 in front of 3, 6, that, somehow my formula changes. And that's not true. The order of the y's and the x's is not important. The only thing that's important is that you stick with the same order that you start with. Let me give you an example. Our y's here are 2 and 6. Now I could do 6 minus 2, but I could also do 2 minus 6. The only important thing is that whichever order you choose, you stick with it. If I start with 6, I have to start with 3. if I start with 2, I have to start with -2. Regardless of the way you do it, these are going to end up giving you the same thing. I'll prove that in another video if you're really curious, but for now, let's just pretend that I'm right. And 6 minus 2 will give you 4. And 3 minus -2 gives you what? That's right, it should be 5, so our slope is 4/5. Yay. Call that m. And now this is the tricky part where everyone sort of gets confused. What do you do with this slope? The correct answer is that you should plug it in for m in our formula. That's why we defined it as m. This is y equals not mx plus b, but 4/5 x plus b. And now the question is, how could I don't know, get rid of some of my variables to just isolate b and figure out what b is? And the obvious answer is I need to get rid of x and y. Can you think of any ways to get rid of x and y? You might have said something like subtract x and y, but that doesn't actually get rid of them. That just moves it to the other side. So what we really need to do is just plug in numbers. And the numbers I'm going to use are up here in these ordered pairs. Now, you can only plug in one number for x at a time, so let's just use whatever looks easier. I'm going to use this one right here. I'm going to use the 3, 6. Now, 3 is my x. 6 is my y. I'm going to go ahead and plug those in. When I do this, I'm going to end up with some kind of crazy fraction. I get like 6 equals 12/5. I ended up having to subtract 12/5 from both sides to get b alone. And I get, something like 6 minus 12/5 is equal to b. Now, I don't know what that is off the top of my head without finding a common denominator. I think it actually is going to end up being something like 28/5, which ends up being a hair over 5.5. And so, for the lack of rounding, we'll just say 5.5 is b. And I now have my formula. We get y equals 4/5 x plus 5.5. I know that was a lot. I'm giving you a lot of practice on how to do these ones. If you think you need more help than just this explanation, please just raise your hand. I'd be happy to help you. Or submit a question on our course website. That would also be just fine. Hope that helps.